Welcome to the Metacrisis, to the history of the Metacrisis. Today I have the pleasure and honor to have with me Professor Eliot Jacobson. He's a famous, world-famous mathematician. He used to be a professor of mathematics and computer science at the University of California, Santa Barbara. And he has been to both sides of the casino end. He was a famous gambler, player that beat casinos out, and he was banned from several casinos. And then he flipped sides, and he became a famous casino consultant. He was even awarded with the Lifetime Achievement Award of the Annual Wordgame Protection Conference in 2022. He has written several books, including The Blackjack Zone, Advanced Advantage Play, Contemporary Casino Table Game Design, and also a poetry book, Totally Disconnected, The Poetic Ramblings of a Socially Awkward Mathematician. So, Professor Eliot, welcome to the history of the Metacrisis.
Well, thank you so much for that generous introduction, and I'm very happy to be here.
I'm very happy to have you. And you are also, let's say, a world-famous doomer nowadays. You have a famous blog where you are talking about the collapse of everything. You study and analyze the weather patterns, the climate change patterns, and the mathematical infrastructure of our climate change, let's call it. And you scientifically analyze and sometimes counterpunch the official statements about climate change.
Yes.
Especially when it comes to temperatures and the rise of the sea temperatures rise, sea levels rise, things like that. So I would like to start by talking about your very interesting life. How did you come to become a mathematician? How your interest was created? And how did you become a gambler and then a casino consultant? Please walk us through your life trajectory.
So a huge question to start me off, but thank you. Yeah, it's hard to boil down my very complicated life, but I was just had a fascination with mathematics from a very young age. I remember back as early as age 5 or so that one of my favorite activities was doing multiplication tables where other kids would be out playing, right? So yeah, I went to college. I started my university as a chemistry major. And sometime around the end of my second year, I decided I did not want to devote my life to creating lipstick. I looked back at what I had, and I had a lot of mathematics courses, and so I changed my major, and I went straight through to a PhD in mathematics in 1983 at the University of Arizona, and then got a position in math in a university in Ohio. And honestly, I enjoyed it for the first couple of years, and then I sort of figured out how unpleasant academia could be. I got tenure, but I started just, let's just, in simple terms, I became a whistleblower, right? I became a whistleblower in about 1995. And about that time, I was looking for something else to do with my mathematics. And so I was a research mathematician. What am I going to do, right? I know the most abstract, arcane mathematics on the planet, and it has absolutely no practical value. So I started research gambling, and I decided to get my hand at blackjack card counting. And I was moderately successful. I was not a big time advantage player, but I was successful enough that I negotiated a buyout of my tenure. I moved to California, got a position at UCSB as a walk-on visiting associate professor of computer science, and started going to Las Vegas, right, all the time. And I did that for a number of years. And somewhere around 2004 or 5, I just decided that was not ever going to pan out for me as a career. I just did not have what it took to put down wagers of $2,000 or $5,000 the way the top players did. And I was contacted by someone who offered me a consulting position on the casino side, and another person who started offering me mathematics projects for the casino industry. And next thing you know, I'm a consultant for the casino industry, right? And yeah, I just that just developed and blossomed very quickly. And so I gave up my university position in 2009 and was full-time in the casino industry until 2017. And that's I just decided to retire. I had had enough, and yeah, so that's pretty much brings you up to today.
That's pretty much a full life and very interesting. And I've read that you've been also walked out pretty roughly one time in your career.
Yeah, I did have one experience where I was put in handcuffs and sort of threatened and brought into a back room, and I had a lawsuit against a casino for their treatment of me. And I don't think that there's anything special to mention, because that unfortunately happens to a lot of people who use legal techniques to beat casinos, that the people inside the casino don't know that those methods are legal and that they have no right to backroom you, to put you in handcuffs and treat you that way. So the lawsuit was quickly settled in my favor. So I'm grateful for that.
Hopefully the mob didn't get interested in you.
Unfortunately, I think they were interested for a little while.
For a little while.
I actually had a little bit of fear associated with that.
Okay, when it comes to climate, how did you turn your interest from studying casinos and cards and counting cards to studying the climate? It is a mathematical model. It is abstract, so it falls in your interest. That's the basis.
So like I say, at a very young age, I really enjoyed numbers, right? So believe it or not, as a child, I used to listen to a local radio station, KFI, out of Los Angeles here, and they would have weather on the 5. So essentially every 10 minutes, they would give a weather forecast. And I used to keep handwritten notes on every temperature they predicted. And went on and on. It was just sort of this fascination of mine. The very first college course I ever took, before I entered college, the summer before, was Introduction to Meteorology. As a professor, I was actually the advisor to the undergraduate meteorology major, and I taught a lot of those courses. So one of the things I used to do as a professor is ask my students to record local weather forecasts and then do a statistical analysis sort of after the fact of how accurate those forecasts were. So this has been sort of a lifelong passion of mine, quite honestly. It's not something that I just stumbled into after I retired. And it's sort of, the rule is that if you want to know how to have the best retirement, what you should do in retirement, the answer to that question is find out what you did as a child that you really enjoyed that you never got to do as an adult, right?
That's valuable. That's valuable.
So for me, it goes all the way back to this little 5-year-old or 6-year-old listening to the radio, writing down numbers, right? It's just been a fascination of mine my whole life. And so that's what's playing out now in many ways. I still have that fascination. One of the very first things I do every single morning, I mean, it's hard to believe I do this, but I cannot wait to get onto the database and see the daily updates for Antarctic sea ice extent, Arctic sea ice extent, North American sea surface temperatures, global sea surface temperature. I mean, all of this data, right? I have spreadsheets for it, and I'm just plugging in the values and updating the graphs, and it's sort of just a passion of mine to do this, and which is one of the reasons, and you may get to this later, that I was sort of first out with some of this data that sort of hit the headlines last summer, right? I was sort of first to say, hey, what the F is happening to our planet right now? Look at this. And it caught a lot of the climate scientists flat-footed and sort of absent of any sort of reasons behind that, just because they weren't paying attention the way I was. And, I'm just a guy sitting in my garage in Santa Barbara with a computer, right? And these are large institutional organizations and academic organizations involved in processing this data. So I was just as surprised as anyone that I was ahead of the curve on these things.
Yes. And your curves and your stats and your imaging of the stats are actually quite informative and quite scary.
Yes.
They create fear.
Yes.
Let's call it, they created it, because if you look at them, if you really study them, you understand what is happening right now to the climate, to the world level. And the first reaction that you get is, okay, what we're going to do now? This is really scary. This is frightening.
I agree with you. I don't intend for them to create
I understand
fear,
that you don't. Of course you do.
But I'm with you 100% on that. You know, if people say, Elliot, you're fear mongering, it's like, no, I'm just, this is just what the data is. If you experience fear, that is just because the data is scary, right?
It's scary. Yeah. I totally agree with you. You have tens of thousands of followers in Twitter and social media. What is the reaction that you get ordinary? How people react?
I have
information that you post.
I just have a lot of gratitude coming from people. I have people sending me direct messages all the time and emails. I make my email available, so people just track me down and send me direct emails. And so I have a fairly universally positive response to what I do. I've had some pushback from climate scientists who have actually helped me in several cases better understand some of the models and some of the way they track data. And I've also, of course, have a constant onslaught from the denier fringe.
The deniers.
Right. And so I, on Twitter, at the very least, I will oftentimes block dozens of accounts every single day. One of the things that I do that I think separates my Twitter from other accounts that might have similar data is that I am very vigorous in blocking all of these accounts. And I think that adds a lot of value to my posts because people are able to read through the threads and have good content there and not have to filter out all the bullshit that's coming along with it.
Yes.
So, you know, the reaction, and of course, I have some bots that every single day I get bombarded
bots.
yeah, with bots putting up pornography on my
yes.
So I have to deal with that every single day. But you know, it's just part of my personality to be sort of obsessive like this. And so it's just fine by me to be monitoring this. But yeah, I would say that people are very appreciative that I have the ability to sort of pursue arguments through data in real time and give my own thoughts on it and not have it clouded by the fact that it has to be peer reviewed and published in a journal or it's coming out from the Met Office or from NOAA or something like that. This is just Eliot saying what his analysis. And so I write articles where I try and explain my analysis, my methodology, right? So that people can respond to it from the scientific community and argue against it if it's incorrect. And in some cases,
do you get some responses? Do you get some responses from the scientific community?
I do, and I have made a few mistakes along the way, and I'm very, very grateful for those people who have given me advice and explained how things happen in ways that I didn't fully understand before. And so I think another point is that as a former academic myself, I actually am greatly appreciative of academics and the academic process to do research and to publish research. And I think that a lot of people who aren't or were never in academics may come off sort of as arrogant towards academia, as belittling it, as saying they have another agenda or they're paid off by their funders or whatever it is, right? And one of the things you'll find with me is that I'm always respectful of the academic process. And I think that also allows the academics community to not just want to directly reject me, right?
Yes,
outright.
Yes. They discuss with you. At least they hear you and they respond scientifically. They don't take it personally.
No, and I'm not, I except in the cases where a couple of academics directly attack doomers, right? And you probably know who I'm talking to, you know, but if they just want to argue the points, I'm willing to argue the points and to learn if there's something to be learned from them.
Yeah, you know, I have studied a lot of the accounts of deniers, and they never get the attacks from the sex bots that you are getting or the doomers are getting. Why do you think that is?
I mean, I don't know.
Do you think it's a strategy? Do you think it's because there are big political agendas involved? Green transition in the US, major capital investments in different kinds of industries, fossil fuels. We're talking about trillions and trillions of dollars. So when it comes to people like you and I don't know, other scientists talking about issues that are hurting their interests, they are getting a lot of public attention, one, and a lot of counter fighting on the other hand. You are the punchback of big industries.
I think that's very accurate. I don't know, because I never read or follow any denier accounts. I go out of my way. If I identify an account, it's immediately blocked and I wouldn't read that content. So I don't know about how they are treated by the bots. But I do know.
I have spotted, I don't know, 1,000 accounts. I have read consistently through the comments. They never get attacked. Their message gets multiplied.
Okay.
This is fascinating.
I think that that's consistent with other information that I have from other sources. There is sort of a what do they call it? The counter disinformation from government levels and industry levels, you know, where what they'll actually do is they'll target certain accounts specifically. And I think this is something that at least was very well known during the heydays of the pandemic, you know, that certain disinformation was more likely to be seen than, for example, scientific information, right? Yes. So I think it's very similar in many ways to that. And I have often argued that I am the victim of military, government, and industrial, attacks by these coordinated trolls. And part of the evidence for that is that there is sort of a consistency to the line of attack they use against me, right? So the most recent one, for example, is the urban heat island effect. So now the claim is that the temperatures have risen because the thermometers that are taking these readings are in more urban areas as population have expanded, and therefore there's more heat from those urban areas, and so the readings are higher, which is total nonsense, right? Because I mean, these readings are cross-checked with satellites that are not subject to any sort of effect like that, and ocean temperatures, oceans are 70% of the planet, are certainly not going to be near urban heat islands. So these sorts of when you get this coordination of attacks by trolls, right, then you know that they're all feeding from the same source. And you can sort of watch that over the days. I mean, another one they'll typically use is you might, on a given day, everybody's saying, well, the Earth is 5 billion years old and your records only go back 120 years, right? What kind of, cherry picking is that? And they'll use the word cherry picking, right? So so I mean, it's fairly evident that that's happening to me, that I'm getting coordinated attacks. I don't know exactly the source of that, but unquestionable.
Okay, yeah, I totally agree with you that it is unquestionable. Walk us through your data. Tell us what is happening right now at the climate, at the world level. What do you see from your patterns and from your maths?
Well, it's such a huge question. You want to focus in on one thing, and I could go in so many different directions. Let me just give you the latest thing that I did that sort of contradicts the mainstream narrative. And so the biggest question on the table is this Paris limit of 1.5 C, right? When are we going to cross 1.5 C? And that question underlies all of sort of the initiatives we take the green initiatives, the governmental and industrial initiatives to clean up carbon, to capture carbon, to go electric or develop wind. And the problem is that there is no consistent definition for the current global anomaly. How far above are we above the Paris limit? And so I did a little media search to look up various sources, whether they're NOAA or the Met Office out of the UK or just some Google AI bot. And I came up with values all the way from 1.1 to 1.3 as sort of the consensus. And then I watched a video by kind of a famous climate scientist who said the exact value that we were 1.26 C right now above the Paris limit. So I kind of thought that was ridiculous. And I posted this vitriolic tweet about how inane it is that we ask what the temperature is today based on the previous 20 years or 30 years, right? That's crazy, because obviously that's in the past, and the temperature today can't be the average of these past years in a changing climate. And when I did that, a climate scientist responded to me and he said, no, the way we do it is we take the previous 10 years of actual temperatures and then the forecasted 10 years for the next the models will predict what the temperatures will be for the next 10 years. And we average those 20 years together. And sort of a light came on. It's like, oh, that makes sense. That way you have a 20-year, which is the minimum they want, time span, right? And the 10 years of actual and 10 years of models. Well, so I did that computation. I took the data from Copernicus, which is the European data, which is the most respected data on the planet, right? And I did, the first question I asked is, what is the current rate of warming? How fast is the planet warming right now? And to get that number, I don't have access to all their models, so I just did the most naive thing possible. I just plotted every temperature from 1850 to 2024. Actually, not 1850, 1940 to 2024, because that's when the data starts, right? 1940 to 2024. And I simply asked, how fast is there a trend line for how fast the planet has been warming that I can put into that data? And when I did that, I came up with a decadal warming rate, how fast per decade we're warming, of 0.3 degrees Celsius. So fine, now I know the previous 10 years of data, and I know how fast the planet is warming going into the future based on this trend line. And that allowed me to come up with a number. And my number is the planet is currently at 1.38 degrees Celsius above the 1850 to 1900 baseline, right? Which is higher than the Met's 1.26, and it's higher than that range of 1.1 to 1.3. And my work is robust, and it's there for anybody to analyze and say, oh, Eliot, you got it wrong. No one has yet. And the same climate scientist who gave me this idea, I shared this result with, and his response was a thumbs up, looks fine, So
yeah, and why didn't you ask why didn't yours looks fine too? Why do we have this discrepancy between numbers?
So I just learned,
26 to 1.38, that's a huge difference actually in climate science.
So I know why that is. I just learned why that is today. So it turns out the Met Office with their 1.26 used the same methodology as I did, all right? But their data is skewed low. And the reason is that, and this is the most bizarre thing, that their 1850 to 1900 baseline is actually marginally higher than the European 1850 to 1900 baseline. They disagree about that baseline. And because they
Okay.
disagree about that baseline, they disagree how much warming there's been since then.
The average is smaller than in the US. So the average per decade is smaller.
And also the average per decade is smaller. Yes, they are still saying 0.2 C as the decadal
because
average.
if they start with a different baseline, then the average per decade is becoming smaller.
Exactly. And so, I mean, those two things together explain all of the difference between our results. And so I'm fully confident in my result, and it completely contradicts the mainstream climate science narrative, right?
Yeah.
So
but even with their numbers and even with their rate of warming, we're talking about reaching 1.5 in 10 years or less.
So with their rate of warming, the prediction, if you think they're saying we're at 1.26 and the rate of warming is 0.2, then they're talking about slightly more than 10 years. Yeah,
13 years.
Yeah, 12 or 13. If you look at my values, 1.38 with 0.3 warming,
5 years.
then we're talking about less than 5 years. Yeah, which to me intuitively feels right. I mean, my numbers sort of have passed the smell test to me, based on what I'm seeing happen globally right now, right? So
for me too, we didn't. I was telling you before starting this recording that this year we didn't have any winter in Greece. We are counting winter per days, not per months. We have had 4 days with temperatures below 10 degrees C, which is pretty. You cannot really comprehend. Right now, the average temperature during decades, I'm 47 years old, what I remember the climate to be is it was around 0, 2, -2, something like that. Today, we have 17 degrees.
Yeah. Well, of course, where
Christmas
you live,
time, we had 25 degrees on the Christmas day. I was on the beach.
You live in one of the fastest warming places on the planet. And of course, the problem is that the North African climate is moving across the Mediterranean into Southern Europe, right? And so that's exactly where you are. So, you know, you're going to be...
2 days ago, the highest recorded temperature in Europe was in Malaga, Spain, and it was 34 degrees C. 34.
In January. Yeah, it's crazy.
In January. This is,
just crazy.
This is Sahara already.
So this is why I feel like my value feels more accurate. And I mean, it's also in the context of the year 2023 that was so remarkable in terms of the records that were broken, that it's just hard to say 1.2 with a straight face, you know, in the context of what happened last year. So at any rate, so that's
even at the long scale of things, having 1.5 crossed within 5 years or within 10 years or 12 years, the difference is actually nothing in the big picture. We are moving fast to unprecedented record warming.
I would kind of agree.
We are going to cope with it.
I would kind of agree with you, but I think, yes, on timelines that are not tied to a human lifetime, things are moving at an unprecedented rate. But if you think about, you know, actual civilization and how fast is that going to collapse? Is it going to collapse in a decade, in 5 years, in 20 years? There's a huge difference there in terms of the total suffering that takes place on this planet. So, you know, this is really, even though it makes no difference sort of, you know, existentially, whether it's 5 years or 15 years, I think in terms of the life on this planet and how it's going to impact it, it does make a difference. And, you know, we're going to see that happen. I mean, it's already happening in many places. We're going to see it expand very, very quickly.
How do you think we can cope with this change? This is unprecedented in our history, and we never cope well with changes.
I don't believe we will cope well with this change either. You know, have a list on my blog of 40 consequences of climate change, right? The top 40 consequences. And fascism is one of those consequences, and mass migration, and disease, and starvation, and hunger, and increasing violence. I mean, all of these things are how we're going to cope. Unfortunately, we're going to cope in very real terms with increases in all sorts of horrible things happening on the planet. And the question is there a solution, a way to stop that? And the answer is no, there isn't. There's simply making as many people aware of it as possible, because the more people who become aware that this is our trajectory, right, the more potential to mitigate that suffering, to understand that we need to start sharing resources, we need to stop destroying ecosystems. So I am, for example, anti-green, right, which comes as a surprise to many people. I consider myself an old school environmentalist. I grew up, I went to my first Earth Day in 1977, right? So I am an old school environmentalist, which means I want to...
1977 was the year that I was born.
Okay. I was at UC Davis seeing Timothy Leary talk about going into outer space, and he predated Elon Musk by 40 years there with that dream. But the point is that, okay, I got a little distracted, that I'm an old school environmentalist, which means that I am against any technology that further degrades the environment. And if that means lithium mining or copper or cobalt mining or scraping seabeds or, building out nuclear or all these things, right, that further destroy the environment. I don't want to see huge expanses of desert covered with solar panels and destroying those ecosystems. I don't want to see huge swaths of ocean covered with wind turbines having unknown effects on sea life in there, right? What I want to see is humans giving up this notion that they are entitled to travel, that they are entitled to all of the possessions they have, that they're entitled to vehicles, that they're entitled to eat factory farm foods, right? All these entitlements that we sort of have conditioned ourselves as a norm of life. I would, if you ask me, what would I rather see, a lithium mine or a regulation that makes traveling beyond 20 miles from your home illegal except in emergencies, right? Which of those two would I choose? I would choose a restriction on travel, right? So that will never happen, of course. But that's what it means to be an environmentalist.
Well, I don't believe it will never happen. I believe it will happen the hard way. Degrowth is what we should do. Post-growth is what will happen. We are moving fast for a post-growth environment. Yet the mentality, the notions installed in our hand are for eternal growth. This is the public discussion. This is the political rivalry about. And this is why polarization also happens.
Yes.
Especially in the US right now, you feel it quite well. This polarization of the US politics while you're moving for the elections is absolutely nuts. You are the strongest country ever existed on the planet. You hold the biggest armory and weaponry and military capabilities all over the centuries. And yet you don't have a constituency, a polity that can direct this power.
And I mean, it's a good point. And another point in that regard is that neither political party is willing to take any of the actions that are required to, one might be considered sort of more environmentally friendly than the other. But, if you were to ask me, would I prefer, say, a Republican view that we need to dig out more coal and fossil fuels, right, and liquid natural gas, or a Democratic view that we should have more green technology, more electric, more wind and solar, right? Which of those two would I prefer? Well, I would prefer neither one of them, right? I don't want either one of those two things. So it's sort of a complicated question. You know, the moral question of which way I would vote is based on other issues, right? So, for example, I'm very much pro-choice as a, you know, and for women's rights, and a strong believer in equal rights for, you know, the whole thing that's happening right now in the university is they're trying to reverse these policies for
freedom of speech.
Well, they're reversing policies for hiring, right? Where you have to have equity, inclusion, and diversity. And so there's sort of there's a movement now on the right-hand side, on the right, against those policies, equity, inclusion, diversity. And, you know, I find that to be just the product of white male entitlement and totally grotesque in every way,
Yes.
you know. So, you know, for me, the politics is not about environment, because I don't think either one of those two parties in this country is going to make the right choice. But
Which is
about
a scheme, because you have the power, you have the means to put the agenda to the international community, to strive the dialogue, to create a framework for the right decisions. And if you are not going to do it properly, who is? China? Or I don't know, the underdeveloped countries who what they are trying to do is create the American dream for their own people.
Right.
So they are copying the American model, and they are multiplying at the extremes. The Chinese, I don't know, their population is 6 times the American, so they need 6 times the fossil fuels that you needed 50 years ago.
Right. So, I mean, that is another point that is often overlooked when you talk about sort of climate justice, the topic of climate justice, that it's not so much that these other developing countries are saying to the US, hey, we want you to scale down so you're like us. They're saying, hey, we want to develop our country so we can be more like you. So what that really means is that there's this huge sort of built-in growth paradigm in terms of fossil fuel and pollution, right? That's going to come out of that growth that is sort of factored into the whole green movement, into the whole climate justice movement, right? Rather than climate justice saying, hey, we need to slow and degrowth Europe and have degrowth in the US and China and India, right? It's like, no, Africa should grow and develop and have roads and cars and infrastructure. So that's a huge problem, and it's just part of the acceleration towards collapse that we're experiencing, is this sort of misunderstanding of the paradigm we're in.
Yes, this we see right now in Europe. We have huge protests from the French farmers.
I saw that.
They have blocked Paris because they ask for discounts on their fossil fuels.
Right. And
to
actually,
keep the energy paradigm thriving.
right. And actually, the people, the 2 individuals who recently threw soup on the Mona Lisa were in support of the farmers, right? They weren't Just Stop Oil. They weren't Extinction Rebellion. They were supporting the French farmers.
Which is absolutely nuts, because you understand that people don't really get the point of time that we find ourselves in, our predicament. They don't really understand, or they don't care. Some people don't even care.
Yes.
Different agenda. Exponential technology. You have also been a professor of computer science.
Yes.
Right now we see artificial intelligence and all these large language models developing pretty fast. There is also a doom scenario there. What would your possibility of doom be due to artificial intelligence? This is a new number that I find from artificial intelligence scientists. Doom.
So, I mean, it's a great question. I mean, it sort of comes about in many different ways, but I mean, the scenario that's often spoken about is you simply ask an AI, can you please solve the problem of climate change that's happening on the planet, right? And so, when AI says, okay, what do I need to do to solve climate change? And it realizes humans are the problem and says, oh,
Yeah,
what we need to do is, and the optimal solution is
get
to
rid of
depopulate the
humans.
planet, right? So, I mean, that's one scenario that you can easily play out. I mean, there's also just AIs being used to subvert infrastructure, right? To find backdoors to write viruses that defeat known ways of identifying them, to play out World War scenarios. I mean, to help develop new viral virus. To engage in biological warfare. I mean, there's all sorts of uses that are nefarious for AI. And I am not one who thinks that AI is going to beat us to the punch. My nephew is quite definitely in that camp, and I have other friends who are doomers who think it's going to be AI that gets us before climate change. I just don't think so. I think that it's one of these things where sort of the public has taken hold of these first large language models and a couple of warnings from industry insiders, but we're really not anywhere in that framework. I mean, I've actually asked. Go ahead.
Well, I believe that also the societal impacts of large language models and AI, the real job loss, for instance. It's huge. So the societal challenges are going to be huge. The fights within societies are going to be huge, because when people lose their salaries or their money or their income or their jobs, they have plenty of time to start fighting with each other. This is I've been reading an analysis of the International Labour Organization. 96% of jobs registered right now, 13,000 jobs out of 13,400 are going to be lost within 10 years. So what are you going to do with a population that is not needed anymore as a working force, neither as a military force? Because in all previous centuries, we needed people, the elites needed people, either as a working force, working the fields or working the manufacturers, the industries, or as a military people. Right now, both these big categories of occupation are getting vanished, are becoming obsolete. So what is going to be the new paradigm, the new societal paradigm to move to? We don't have an answer.
Well, I can only agree with you. The one thing I would say is that this is just one element of collapse. The lack,
yes,
the recognition of loss of meaning that people are finding, the existential issues of purpose of life, in absence of something to strive for with a career or a way to carry you through your days. I think that's already happening to a large extent, and you see that playing out in other ways. For example, this whole notion of doom spending. I don't know if you've come across that young people are now no longer saving for retirement. They're treating themselves to vacations and luxury products, and any sort of sense of responsibility for the future is going away, right? They're not having children in the same way anymore. And so there's a whole paradigm shift happening in our youth right now that's actually starting to become apparent as these people age into sort of, their 30s and so on, that we're seeing the future that you're predicting, right, with AI already happening, but it's happening irrespective of AI, right?
Yes.
So yeah, I think that's one facet of a very complicated future, and it presumes a lot of other things are stable long enough for AI to actually
to
take on that
create
role.
New havoc.
Yeah.
But also for AI to get boosted, it needs enormous amount of energy and water.
Yes.
which are clearly lacking right now. And yet we see it developing, which means that the people that are developing these technologies are making the decision to take these resources out of the societal balance and put it in the technological balance, which is also pretty scary in and of itself as a choice, as a political choice, because there is always the question of energy.
Right.
Richard Heinberg put that quite well in his recent book, Power, of Post-Carbon Institute. The question of energy keeps coming and coming back to our minds. But the political discussion never puts the question of energy within the spectrum of political decision-making, at least of democratic political decision-making. Ordinary citizens never hear about energy. Economists don't talk in the universities about energy, while energy is the prima facie instrument of power.
So just so you know, your video is a little bit delayed. So I'm actually hearing you when you're not talking, and I'm seeing your mouth move, and I'm not hearing any words. So if I get a little bit sort of off sync with you, it's because of that. And I assume it's because we're halfway around the world from each other.
Yeah.
And I'm having a super storm come over my head right now with this rain. Well, I'm not an expert on the sort of question of energy and its relationship. But I mean, it's certainly the case that at the end of the day, everything is about energy. The energy, I mean, the key problem, if I move this back to climate, the key problem on the planet is what's known as the Earth energy imbalance, right? Which is this idea that greenhouse gases really, yes, they trap outgoing thermal radiation, but there's a lot of ways that the planet can heat up. And at the end of the day, the only thing that really matters is the planet absorbing more energy than it's radiating back out into space? And the answer is yes, it is. And the primary cause of that is greenhouse gases that trap some of that outgoing thermal radiation. So I don't know if I'll just share this number with you, and it's one of the statistics that I very carefully track. It comes out every single month, and I'm able to update my values sometime around the third week of every month. So this current value I have is through November of last year. And what we're talking about is the net energy imbalance. How fast is our planet heating up? And that current number is somewhere in the neighborhood of, and I'm going to use this Hiroshima bomb equivalent. So if you think about one Hiroshima bomb and the total heat generated by that, we're not talking about the explosive power. We're just talking about the heat, right? So the current planetary heating is about equivalent to 13 Hiroshima bombs worth of heat per second on a planetary scale. So every second,
which is mind-blowing as a number. Huh?
It is absolutely mind-blowing. And what's sort of more remarkable for me personally is the acceleration of that number. So that number was first computed by a climate scientist by the name of Daniel Miller in the early 2000s. And it was given to James Hansen, and he published that the Earth was currently heating at a rate of, I think he said 3. The original value was 3 Hiroshima bombs per second. And then over time, it went up to 4. And if you do a media search, you might find the media saying at some point recently that I think there was one article that said we're heating at a rate of 7 Hiroshimas per second. So this was a case where I decided to do this computation on my own about 2 years ago. And at the time, I came up that we were heating at a rate of about 11 Hiroshimas per second. And I actually published this article and was contacted by the original mathematician for James Hansen. And I just said, am I doing this right? And he said, yes, this is how I did it. You're doing it in the same way. I published my methodology on my blog. I've only had confirmations that I'm doing it correctly. So what it means is that just in the last 20 years, the planet is now heating up about 4 times as fast. We are now absorbing energy, trapping energy about 4 times as fast as we did just 20 years ago. You know, and so when you talk about the decadal heating of being consistent over time, well, how could it be consistent when we're trapping 4 times as much heat today as we did just 20 years ago? How can you say that our rate is the same as it was 20 years ago?
This is impossible.
It's impossible. It makes no sense at all. But I mean, it's just also underscores how quickly collapse is happening. Environmental collapse, the collapse of the biosphere, the collapse of all the systems on the planet, right? The ice systems, the cryosphere. So all of these systems are sort of undergoing simultaneous collapse, along with, of course, our economic and political systems. And the Earth energy imbalance, I think, captures all of that in one number. Right? It's like, this is how fast things are falling apart right now. 13 Hiroshima bombs per second. And, you know, I publish that number every single month, and we have hit over the last year or so, every single time I publish it, it's a new record high. It's a new record high value, right?
It never went down.
Well, it's gone up and down. Yes, it has, because actually solar cycles have some impact, because when the sun puts out more energy or less energy, that's going to have a little. And also things like just the total aerosols in the atmosphere. The more aerosols there are, the more sunlight is reflected back out into space, and so the less is trapped by the planet. So as aerosols change, you get changes, and also aerosols create clouds. And so, you know, some years for whatever reason are cloudier on a global scale than others. Some have more Arctic ice than others, where that more ice reflects back more solar radiation. So there's all sorts of impact, and it's a very volatile number. It varies quite wildly from year to year. So I do actually a 36-month, 3-year running average, which is the same thing that James Hansen does, right? Again, this is how I learned.
Yeah, that's why James Hansen published recently a paper saying that global heat is in the pipeline.
Right. So this is a really interesting problem that he's posing. So, I mean, I'll just give a quick summary. I'm not sure whether people out in your listening audience know about this, but the key number, the big key number, right, that all climate science is based on is called the equilibrium climate sensitivity, or ECS. And they're just asking this question. In pre-industrial days, we were at 260 parts per million CO2. If we were to double that to 520, and then just let the system stabilize, how much would temperatures go up, right? So this is the amount of temperature gain that we get by doubling the CO2 in the atmosphere. And there are these huge arguments about these numbers. There are all these different ways of computing it. And essentially, the IPCC has a range that is lower than the range that Hansen came up with. So Hansen came up with a value that you double the CO2, it would lead to about 4.8 degrees Celsius of global warming. The IPCC
plus minus 1.2.
Say, please.
Plus minus 1.2, which means from 3.6 to 6.
Right. And so there's all these other models that put that value much lower. Nobody is even in the range of what Hansen put out. And so, you know, if Hansen is correct about this, if Hansen's numbers are correct, then the planet is going to heat up much faster than anybody's been expecting. And 2023 was strong evidence in favor of Jim Hansen's research. And so I think what's very interesting about 2024 is that this year is likely going to go a long ways toward determining the sort of which way we go with the ECS. Do we lean more towards Hansen or more towards the traditional models? So, you know, I'm going to follow this very closely this year because it makes a huge difference if we really are in this so-called accelerated warming, where warming is accelerating. And by the way, that's what my own work showed as well.
I see your research every day. You publish your images every day. And right now we have started with full January, exceeding all previous records. Far higher, actually. Far higher.
Yes. Absolutely. And so it's going to be, you know, this year is going to tell a lot as far as changing the minds of mainstream climate science about what trajectory we're on. And if Hansen's work plays out so that he looks like he's more correct than the others, it's going to be an earthquake in terms of the predictions that are made that start coming out from IPCC and from these other organizations. So, you know, that's where we are right now. We're sort of at this very critical moment in terms of understanding just how quickly events are going to unfold. And my work and Hansen and Leon Simons, I hope you'll have a chance to interview him if you have not yet. You know, everybody's sort of in my universe is coming up with it happening faster and being far worse, you know. So we'll see, right?
Yeah, but when we come to accurately predict the future, then this is an instrument that we can turn to political decision making. And this is also what Hansen puts forward. He specifically talk about geoengineering solutions, aerosol created clouds that could distract the energy coming into planets, that could detract it, put it out of space, or reflect it away.
Right.
There are also other solutions out there, but predicting the future accurately and knowing what the real numbers are is an instrument much needed. But do you think we have political decision makers that read science, understand science, and can take decision based on science?
So I want to go back to what you said about Hansen's solutions, because he actually sort of had three things that he talks about. One, of course, is geoengineering, like you said. Another one is a massive build out of nuclear power plants. And the third is the creation of a new political party that doesn't take special interest money from any source. And so I think each of those three things is equally likely to happen, which is to say zero chance it will happen. And so what would be interesting to know is what Hansen would predict our future will be if none of those things happen, because they're all near impossibilities. So nuclear is actually shrinking right now globally. It's not growing. As far as geoengineering, I recently did a computation and it was double checked by another organization, so I'm confident in it. But the most effective way of cooling the planet is to reflect incoming shortwave radiation. Never let it hit the planet in the first place, right? And so stratospheric sulfur injection would be a way of creating bright clouds in the upper atmosphere that would reflect incoming solar. But, you know, a much cheaper solution is just to build a bunch of mirrors, because mirrors require sand. Sand is the cheapest material on the planet, widely available. And so we create a bunch of mirrors, and you can coat them with aluminum. And it turns out that one aluminum can coat a huge square footage of mirrors. So we have lots of trash aluminum cans that can now be devoted to mirrors. So the question is, how many mirrors in pure just physical size would we need to cover the planet with in order to just get back to where we were 20 years ago in terms of how fast the planet is heating, right? And so that question, I decided to do that calculation. And what I came up with was 1.6% of the planet would need to be covered by mirrors. Now, you might not immediately know how much of the planet that is. So the United States covers 1.8% of the planet. So roughly we would need to cover about 90% of the United States with mirrors reflecting solar energy back into space. Of course, you couldn't put them in the US because we're not an equatorial region, and so it would have not a direct solar.
effect.
So we need to cover the equator with the equivalent of the United States geographical size with mirrors. So that would get us back to the year 2000, right?
Which is not so bizarre a solution. This could be achievable if it would become a humanity's target.
Well, the
problem is
no, because if we achieve that, then what it would mean is now we have it's sort of like Javon's paradox in reverse, right? This idea that the more energy we create, the more we use, that new energy doesn't replace old energy. New energy creates new ways of using itself, right? So it'd be the same thing with these mirror solutions or with any geoengineering solution. If we were to create a solution that allowed us to grow more without collapsing, then we would just grow more and fill out, to the extent that solution provided. Same with nuclear power. So, these solutions don't create or solve old problems. They just give us more room to grow for a longer period of time. And hence, more environmental destruction.
So any given solution should be accompanied with a degrowth mindset.
Yes.
Decapitalizing our minds, decapitalizing our political systems, creating a new paradigm, a new societal paradigm.
And as well as I do that is never going to happen. Never.
Yes.
Right?
Yes.
So
at least not if it is not going to be imposed. People will never opt for it.
Yes.
This is the problem. You have, especially right now, you have all this different way of looking things, different mindsets, polarized and boosted through the algorithms. You have all these different echo chambers, all these different agendas conflicting with each other. So finding a modus operandi and a modus vivendi at a global level, for me, seems like an impossible exercise.
Yes. Yeah,
well, Eliot,
I agree with you. I'm just, I have this list I posted. It's the ain't gonna happen list. It's just all of these things that people come up with about, how life will change or what we can do to preserve our paradigm for civilization just a little bit longer. And, you can just check off every single one. Ain't gonna happen, ain't gonna happen, ain't gonna happen. Degrowth will happen through collapse, right? That's how it's gonna happen. So, so at any rate, that's just how I'm with you on that. I don't know how else to say. I'm just 100% with you on that.
Yeah. Well, our predictions are not pretty rosy. They're pretty dark. But this is what the situation is. And whenever I discuss it here in Greece, people don't want to listen. They prefer to live in a rosy bubble, in a rosy cloud up there, being happy, doing their everyday stuff, business as usual. But if we do not confront them with real data, with real information, with real science, the hardcore science, mathematics that you do, they will never get our predicament, our real problems of the day. This is what I'm trying to do with the history of the Metacrisis, and thank you for being here. I just received a notice that you don't have much time more. So I need to thank you for being here. My podcast is always open to you. Whenever you have more information to share, please come up, send me an email, and we'll host you happily.
Well, I'm so grateful for your invitation, and the depth of your understanding of this crisis is very well received. And probably like you, there are very few of us who really understand just how serious this situation really is. It's not It's not for the faint of heart. And you want to
Well,
go
in the
doubting it
past,
every day.
before starting this podcast, I thought that I was a minority of one.
Yes.
But after starting it, I'm starting to find more people like me, like you, that know the subjects, that talk about the metacrisis, that talk about the real issues interconnecting and creating a web, an inescapable web of problems. Systems thinking is not hardcore born in us. It's not intuitive. But we need to do our best to bring awareness and bring enlightenment to the general public. That's what we're trying to do. And thank you for helping us in this direction. Thank you for helping me.
Well, thank you again for having me on your show. And I look forward to being on again sometime.
Excellent, Eliot. Thank you very much. My best to California. I hope you are going to escape the floods, which are coming your way right now.
Yes.
Climate change is coming to your home, my friend. Be careful. So thank you very much. We'll talk again.
Very good.